Hello everyone, I'm Mr. Zhang. In this video, I'm going to talk about the transformation of functions. Transformation is the process of changing the positions, the orientation, or the size of the object. In this video, there will be 4 sections. The first section I will talk about translation, and then the second one I will talk about reflection, and then the third one I will talk about enlargement and reduction. And finally, we will go through some examples about the combination of two transformations. And at the end of each section, there will be questions. Please do not skip it and answer it by yourself. Translation is a very simple concept. It means the process of changing the position of the object without changing the size or the orientation of the object. Take this car as an example. I can move this car to the right or to the left, or I can move it upward or move it downward without changing the size of the car or the orientation of the car. And this is translation. This is the graph of y equal to x squared. Now I want to translate it upward by 2 units. Let's see what will happen. First, take a look on 3 points on the original graph, which are 1, 1, 0, 0, negative 1, 1. All these 3 points will move upward by 2 units, so they will become 1, 3, 0, 2, and negative 1, 3. And when we connect those 3 points, the graph will look like this. This time, I want to translate the graph of y equal to x squared downwards by 2 units. Let's see what will happen. Firstly, take a look on 3 points on the original graph, which are 1, 1, 0, 0, negative 1, 1. And each of these points will move downward by 2 units, so they will become 1, negative 1, 0, negative 2, negative 1, negative 1. When we connect those 3 points, the graph will look like this. And now I want to translate the graph of y equal to x squared leftward by 3 units. Let's see what happens. Firstly, we take a look on 3 points on the original graph, which are 2, 4, 0, 0, negative 2, 4. All these 3 points will be moved to left by 3 units, so they will become negative 1, 4, negative 3, 0, negative 5, 4. Then we can connect those points. Then the image of the graph will look like this. Here, I want to translate the graph of y equal to x squared to the right by 3 units. Let's see what happens. Let's take a look on 3 points on the original graph, which are 0, 0, 1, 1, 2, 4. All these 3 points will be moved to the right by 3 units, so they will be 3, 0, 4, 1, 5, 4. Then we can connect those 3 points, and the image of the graph will look like this. In this section, I'm going to talk about reflection. Reflection is our everyday life experience. Every day we wake up, we saw our reflection from the mirror. In this video, we are going to talk about 2 kinds of reflection. Reflection about x-axis or reflection about y-axis. Let's take this car as an example. This car is first reflected about x-axis. So, the image will look like this. The image will turn upside down, and also the image and the object will have equal distance from the x-axis. That means this and this should be the same. And now consider the car is reflected about y-axis. So the image will look like this, which is laterally inverted. And also, both the image and the object will have the equal distance about y-axis. That means these two numbers should be the same. Now, I'm going to reflect the graph of y equal to x squared about x-axis. Let's see what will happen. Firstly, I will select 4 points on the original graph. They are -2, 4, -1, 1, 1, 1, 2, 4. These 4 points will reflect about x-axis. The image and the original point are equal distance from x-axis. So the image of -2, 4 will be -2, -4, and the image of -1, 1 will be -1, -1. The image of 1, 1 will be 1, -1. The image of 2, 4 will be 2, -4. When we connect these 4 points together, we can see the image of the graph. Here, I'm going to reflect the graph of y equal to x squared plus 1 about y-axis. First, I will select 3 points on the original graph. They are -2, -7, -1, 0, 2, 8. And these 3 points will reflect about y-axis. Their image will be 2, -7, 1, 0, -2, 8. When I connect these 3 points, their graph will look like this. In this section, I'm going to talk about enlargement and reduction. There are 2 kinds of enlargement and reduction. The first one is along y-axis. The second one is along x-axis. Let's talk about the first one. Okay, look at this normal car. Now I want to enlarge this car along y-axis, so it will become this one. And you can easily observe that they have the same length. But obviously, this one is taller. And also, I can reduce the car along the y-axis, so it will become like this one. And this one is shorter. The second one is enlargement and reduction along x-axis. And also take this normal car as an example. I can enlarge this one along x-axis, so it will become like this. You can easily tell that this one is longer than the original one, but they have the same height. Apart from enlargement, of course, I can reduce it along the x-axis. Okay, you can see that all these 3 cars have same height, but their length is different. This is the graph of y equal to sine x. Now I'm going to enlarge the graph along y-axis to 2 times the original. For the convenience, let's look at the point 90° 1. The x-coordinate will keep constant, but the y-coordinate will be double, so the image of this point will be 90° too. The y-coordinate of any other point on the graph will also be double, so the image will look like this. This time I'm going to reduce the graph of y equal to sine x along y-axis to 1/2 times the original. For the convenience, let's take a look on 90° 1. The x-coordinate will keep unchanged, but the y-coordinate will be reduced to half. Any y-coordinate of the point on the original graph will also be reduced to half. So the image of the graph will look like this. This time I'm going to enlarge the graph of y equal to sine x along x-axis to 2 times the original. For the convenience, let's take a look on 90-degree one. This point, the y-coordinate will keep constant, but the x-coordinate will be enlarged to 180 degrees. For any other point on the original graph, the x-coordinate will be double, so the graph will look like this. Lastly, I'm going to reduce the graph of y equal to sine x along x-axis to 1/2 times the original. For the convenience, let's look at the point 90-degree one. The y-coordinate will keep constant, but the x-coordinate will reduce the half, so the image of the point will be 45-degree one. For any other points on the graph, the x-coordinate will also reduce to half, so the graph will look like this. In the last section, I'm going to talk about the combination of two transformations. I will show you 4 examples one by one. Example 1. Translate the graph of y equal to x squared upwards by 3 units and then rightwards by 2 units. In this example, we can select 3 points from the original graph, and they are 1, 1, 0, 0, -1, 1. Then we can move these 3 points upward by 3 units, and it will look like this. Then we can move the image of the graph to the right by 2 units. Then the final image should look like this. Example 2. Reflect the graph of y equal to x squared about x-axis and then translate rightwards by 3 units. In this example, we first reflect the graph of y equal to x squared about x-axis. So it will look like this. And then we translate the image to the right by 3 units. Then the final image should look like this. Example 3. Translate the graph of y equal to x cubed leftward by 3 units, and then reflect about y-axis. So firstly, we move the graph to the left by 3 units. So it will look like this. Then the image is reflected about y-axis. So it will look like this. Example 4. Enlarge the graph of y equal to sine x along the y-axis to 3 times the original, and then translate upward by 2 units. Let's consider the maximum and minimum point of the graph of y equal to sine x first. They are 90-degree 1, 217-degree -1, 450-degree 1. After the enlargement along the y-axis 3 times to the original, the image will be 90-degree 3, 270-degree -3, 450-degree 3. When we connect all those 3 points together, we can see the graph of the image clearly. Then we can translate this image upward by 2 units. So the final image will look like this. It is about time to make some conclusion from our previous work. Let y equal to fx and y equal to gx be the equation of the graph before and after the transformation respectively. And let xy be a point A on the graph y equal to fx. Let a pi be the image of A on the graph of y equal to gx after the transformation. If the graph of y equal to gx is obtained by translating the graph of y equal to fx upwards by k unit, then the coordinate of a pi will be x, y plus k. If the graph of y equal to gx is obtained by translating the graph of y equal to fx downwards by k unit, then the coordinate of a pi will be x, y minus k. If the graph of y equal to gx is obtained by translating the graph of y equal to fx leveled by k units, then the coordinate of a pi will be x minus k, y. If the graph of y equal to gx is obtained by translating the graph of y equal to fx rightwards by k unit, then the coordinate of a pi will be x plus k, y. If the graph of y equal to gx is obtained by reflecting the graph of y equal to fx about x-axis, then the coordinate of a pi will be x negative y. If the graph of y equal to gx is obtained by reflecting the graph of y equal to fx about y-axis, then the coordinate of a pi will be negative x, y. If the graph of y equal to gx is obtained by enlarging or reducing the graph of y equal to fx along y-axis k times to the original, then the coordinate of a pi will be x, ky. If the graph of y equal to gx is obtained by enlarging or reducing the graph of y equal to fx along x-axis k times to the original, then the coordinate of a pi will be kx, y. That's the end of the video. Thank you for watching. I hope this will help you in your study.